All right. So we need to wind up with the elimination method as I promised today. So we need to wind up the last phase that I talked about. So our first scenario, we eliminated y, if you remember, and in this case, the coefficients of y were the same. So since the coefficients of y were the same, then it made it easy for us to eliminate. We just subtracted and we eliminated y in that case. However, now what do we have to do in case the coefficients are not the same? For example, if you look at x, the coefficient of x here is 5 and the coefficient of x here is 1. So what would happen if I wanted to eliminate x? So having observed that in the first equation the coefficient is 5 and the second equation the coefficient is 1, we just interchange those coefficients by multiplying them through those equations. So if the coefficient of x here is 1, I'll multiply 1 through that equation. And if the coefficient of x here is 5, I'll multiply 5 through that equation. But don't forget that it has to multiply through the whole of that equation. And also this 5 has to multiply through the whole of that equation. So let us go through it. We start the multiplication. So we multiply together. Okay. 1 times 5 gives us 5x. 1 times 2 gives us 2y. And 1 times 13 will give us 13. As you've already seen, I already know that 1 times any number stays the same. So that's why that equation stayed the same. 5 times x gives us 5x. Then 5 times 2 gives us 10y. Then 5 times 9 gives us 45. Now you can see that that technique has transformed the coefficients of x to be the same. So you can see that now x is ready to be eliminated this time. So how shall we eliminate it? If there is no sign here, that means this is positive, and here it is positive. So same sign, then we are going to be actually subtracting. So can we subtract? Okay, so I'll put that one to subtract there. Good. So as you observe, if I subtract this is 2y minus that, I'll be getting a negative, and that will be negative. So it is better I subtract the first equation from the second one, or I subtract the first part from the second part. So I take this one down, minus that, minus that, minus that. Alright, 5x down minus 5x gives us 0. 10 minus 2 gives us 8y. 45 minus 13 gives us 32. So you've already seen this in one of our previous equations. So how do we get y? For us to be able to get y, so y will be equal to 32 over 8, and that gives us a 4. Again, after having got y as 4, then proceed to obtain your x. Use any of the equations as well. So I use that, the second one, x plus 2y equals 9. So because y is 4, I put it there. 2 times 4 gives us 8. So it means that x plus 2 times 4 gives us 8. And then we have 9. So we know that to get x, we subtract 8 from there, and our x becomes 1. So these are values which you've already seen. So because it is the same equations, so only that we changed what we add to eliminate. Before we add to eliminate y, and since the coefficients were the same, it was straightforward. This time I've started with I tried to eliminate x, and I've shown you how we transform the equations to make the same coefficients. And if the coefficients are the same, then you proceed to subtract. And in a scenario where, for example, let me say this was minus 5x on top, and down we have 5x. So one is positive, another is negative. For us to eliminate this time, we can just add. If one of them is negative, another is positive, add the two to get z. But if they both have the same sign, if they are both negative or if they are both positive, then you just subtract. Alright, then you can now conclude. Don't forget our mathematical symbol we talked about, that after I've finished solving my simultaneous equations, then I'll say that therefore my x is equal to 1 and y is equal to 4. So basically that is the elimination method. So we've seen both scenarios, a situation where the coefficients could be already the same, and another situation where the coefficients might be different. And when the coefficients are different, transform by choosing the coefficient in one of the equations to be multiplied into the other equation. And then the coefficient in the other equation multiplied in the other equation. So that will make the coefficients to be the same. So don't forget that when you are doing this, get other simultaneous equations which you can try out for you not to forget. It's always good that when you are watching these videos, you have your book, you are writing down, you try to solve along. And again, get other equations that you will be solving using the methods. So in the next video, we shall be discussing the graphical method. And then finally, we shall see the applications. Where do we apply simultaneous equations? How do they assist us in our everyday life? So this is coming up in the next videos. So again, you have to check that if x is 1, we've checked before. If x is 1, so 5 times 1 is again 5. Y is 4. 2 times 4 is 8, so 5 plus 4 is 13, we've already seen that. X is 1, that is 1. 4, 2 times 4 is 8, and 1 plus 8 should be able to give us 9. You can always do that counter check to ensure that the values you've got are really the ones which satisfy the simultaneous equations. See you next time in our next video. Have a very nice day.